All right, so here we have a conservation of energy question, and I think this is a good practice problem to, I guess, introduce yourselves to conservation of energy. So let's start. So the question states, suppose a 2,000 kilogram mass was traveling at a speed of 20 meters per second, right? So we have our mass and our velocity here, initially for our first mass. Now this mass transfers all its energy to a mass of 10 kilograms, right? What will be the velocity of the 10 kilogram mass after being hit by it? All right, so the first thing I did was I kind of drew a little bit of a rough diagram here, right? So you're not really necessary to draw it as a bigger ball, but I did so just to visually show that. So we have mass 1, right? Our 2,000 kilogram ball, and mass 2, which is our 10 kilogram ball. So this ball is coming at a speed of 20 meters per second. It's going to hit this ball, and we're going to try to figure out what its velocity is. So what we're going to be using is the conservation of energy, right? Energy is conserved. That's something you have to understand, right? So for this, there's one really good formula, and since it's in a linear fashion, not involving, I guess to say, any gravity, right? So what we have to understand is that the kinetic energy, right? K is equal to, Ke is equal to half mv squared, right? So what you basically have to do is you have to find the initial kinetic energy for this ball, correct? And from this, you can easily find the velocity for mass 2, right? And I'll be showing you how to do that. So according to conservation of energy, what you would have to understand is that the Ke initial should be equal to the kinetic energy final. When I say Ke, it just means kinetic energy. So my kinetic energy initial should equal my kinetic energy final. So let's write this out. So my half m1, because mass 1, v squared is equal to half mass 2. I'm going to write v1 actually is equal to mass 2 v2 squared. And that's it. All we're basically going to be doing now is we're going to be isolating for our v2, right? And when we isolate for our v2, we can just plug in our numbers and we should get it. So it's going to be, I'm going to multiply by 2, and when we multiply by 2, this half gets canceled out. So all that it remains is just m1 v1 squared is going to be equal to m2 v2 squared. And from there, I'm just going to be dividing by m2 and taking the root of it. So it's going to be m1 v1 squared over m2 is equal to v2 squared. And then therefore v2 is going to be equal to the root of m1 v1 squared over m2. All right, now from this, let's just plug in our numbers and figure out our answer. Put a little arrow here so I don't know where I'm going. So our v2, I'm going to put in blue, our v2 is going to be equal to the root of mass 1 in this case, which is 2,000 kilograms. It's in kilograms, so that's great. We don't have to do any conversions. And then we do 2,000 kilograms times the velocity of that object, which is 20 meters per second. And remember, it gets squared, so let's square it. And it's going to be all over mass 2, which is our second mass, which is 10 kilograms. And now let's calculate it. You can use a calculator for this. So it would be 2,000 multiplied by 20 squared. Okay, and then you divide that by 10, and then you would take the root of that. And that should give you an answer of 282.84 meters per second. Now you can adjust this to significant units if you like, right? And that depends on the question, right? So for now, this is just a general answer, but according to your teacher's requirements and what they are expecting for your significant digits, you can adjust it. But this is in generality how you can use conservation of energy to, I guess in this case, find the velocity of the second object. And that's it. I hope this video helped. Have a great day.